Hello, pre-calculus students. In this video, I'm going to show you another example for solving trigonometric equations. And if you look at this example, you might be a little bit scared. There's a lot going on here. We've got our trig function, and we've got a squared, and we're asked to solve for the angle. And so we really want to break this problem down so we're not as freaked out by how scary it looks at first. So I want to start by just going over some simple problems that you'll remember from Algebra 1, Algebra 2, and pre-calculus. And then I'll show you how being able to do these simple steps is really enough for being able to do this big problem. Okay, so here we go. Let's start all the way back in our happy Algebra 1 days. These are two linear equations, and we're asked to solve for x. So you might remember, to solve this one, you just want to subtract 1 from both sides, because you are trying to cancel out this positive one. We're trying to undo this positive, so we get x by itself. So in this equation, x equals 0. In this one, I'm trying to get x by itself again, so first I have to add 1 to both sides, and then I'll have to deal with this 2. So I end up with 2x equals 1. And now, in order to get rid of the 2, I need to divide both sides by 2, because division is the opposite operation of multiplication, and we're trying to sort of undo the fact that we multiplied x by 2. And this is a common theme in math, the process of doing the opposite operation. So these are things, solving these two equations, you should feel pretty comfortable with that because you've been doing it for quite a long time, all the way since Algebra 1. Now let's look at a slightly scarier equation, a quadratic equation. So up here, we had linear, which means the degree on the x was only 1. Here we have quadratic, which means the degree on x is 2. So we didn't really learn how to deal with these types of functions until Algebra 2. But you might remember, let's write quadratic here, that in order to solve an equation like this, we really want to boil it down to linear equations because those are easy for us. And so our first step is going to be to factor. Let me actually do this in a different color. We'll use a light green. So to factor, I want to take this quadratic expression and separate it into two linear pieces that when I multiply them together, I get this quadratic expression back. So if you remember, it's kind of the reverse the FOIL process. So when I say FOIL, I mean multiply two linear terms together to get a quadratic one. Now we're breaking up the quadratic one into two linear terms. So this term and this term need to multiply to give us 2x squared. So the best way to do that is 2x and x. That's the first times the first equals the first. We also know from FOIL that the last times the last is supposed to equal the last. And so the only way I can multiply to get 1 with integers is 1 times 1, and it needs to be negative 1. So one of these has to be negative and one has to be positive. To determine the sign, I look at the middle term, which is going to need to be positive. So when I do outer plus inner, I'm supposed to get a positive number, which means the outer is going to get the plus because that's going to give me 2x. The inner is going to get the minus. That will give me x. So minus x. So when I do 2x minus x, I get positive x. Now, take a look at this. I have two linear factors that multiply to 0, which means that one of them, at least one of them, has to equal 0, because the only way I can have two things that multiply to 0 is if one of the factors is equal to 0. So we've got these two expressions both equal to 0. See any patterns? This equation came from the Algebra 1 example. We already solved that. And this linear equation was this Algebra 1 example, and we already solved that. So we can see from here, if I were to use the same exact process as Algebra 1, I get x equals 1/2. And here, if I use the same exact process as from Algebra 1, I get x equals -1. So the only thing that's different here is we had to factor first, but then we just applied our Algebra 1 skills again in order to solve for the two solutions. So just take a look at that for a moment, and then we'll move on to a pre-calc example, which seems at first disjoint from everything we did here, but when we put it all together, you'll see how it fits. Okay, so I'm going to move this away for a moment. We'll come back to it. Here is our pre-calculus example. In pre-calculus, right now we're studying trigonometry, and so you've solved a bunch of equations like this for an angle. So here I have one equation that says sine of theta equals 1/2, and I want to know what angle theta is. Here I have the equation sine of theta equals -1, and I want to know what angle theta is. So what angle has a sine of -1? What angle has a sine of 1/2? The way that we've been solving these problems is by using our handy-dandy resource, the unit circle. And we know that sine of theta is the y-coordinate that's attached to the angle theta. So sine is y, and cosine is x. So for example, looking at my unit circle, if I want to know the sine of pi over 3, I go to the angle pi over 3, and I read the y-coordinate. It's √3/2. The cosine of pi over 3, since cosine is the x-coordinate, I go to pi over 3, and I look at the x-coordinate, it's 1/2. So my problem is asking me to go in the reverse direction. If sine is 1/2, what was the angle? So I'm going to look at all the angles that have y-coordinate, which is sine, equal to 1/2. So let's find them. Here's one where the sine is 1/2, and here's one where the sine is 1/2. If I look at the other y-coordinates, these are negative y-coordinates, so couldn't possibly have an answer down here, and the other y-coordinates are not equal to 1/2. So what angles had sine equal to 1/2? Well, the angle pi over 6 does, so that's one of my answers. And the angle 5 pi over 6 does, so that's my second answer. I'm going to use the same procedure to find the angles that have sine of theta equal to -1. So I'm looking for a y-coordinate of -1. Do you see it? It's got to be down here somewhere. And it's right there. -1 is my y-coordinate. So what angle has a sine of theta? What angle theta has a sine of -1? Well, it's 3 pi over 2. All right, so we've done 3 different mini problems. An Algebra 1 problem where we solved linear equations, an Algebra 2 problem where we solved a quadratic equation, and a pre-calculus problem where we solved 2 trig equations. Now let's come back to our big example. And let's notice some things about this example. The first thing I notice is that it has trig functions in it. Sine of theta. The next thing I notice is that it is quadratic. The sine of theta is squared. And so I'm going to have to use my pre-calculus skill at some point to deal with the sine of theta. I'm going to have to use my algebra 2 at some point to deal with the quadratic, and we know that whenever we deal with quadratics, eventually they boil down to linear functions. So let's work this out. Step 1, I want to make this look like an algebra 2 problem first, because whenever I solve equations, I work from the outside inward, and my innermost piece is the sine theta. So the pre-calculus step, the trigonometric part, is going to be my very last step. And so my step 1 is going to be to substitute. And what I'm going to substitute is I'm going to turn sine of theta into an s. I'm using s just so that I remember that it's taking the place of sine. I could use x if I wanted to. So instead of the sine theta here and here, I'm going to use s. So now I have 2 s squared plus s minus 1 equals 0. My step 2, well, can you guess? Doesn't this equation look a lot like this one? My step 2 will be to use algebra 2. So I know that my two answers, well, I can even show this step. It's going to factor as 2s minus 1 times s plus 1 equals 0. And then my step 3 will be to use algebra 1. So maybe here we just factored. That was our algebra 2 step, really, was the factoring. So my step 3 will be to use algebra 1 when I set each of these equal to 0. Now I have my 2s minus 1 term and my s plus 1 term, and I know that I want to set each of those equal to 0 and now solve for s. So I do my algebra 1 steps. This equation tells me that s equals 1/2. This equation tells me that s equals minus 1. My step 4 will be to put sine theta back in for s. So I had sine squared theta here, sine of theta here, that became s squared and s, and it became s and s, s and s, s and s. So now when I put sine back in, I have sine of theta equals 1/2, and sine of theta equals minus 1. Step 5 is to use my pre-calculus step. The two equations that I arrived at are the two equations that I already knew how to solve. So I have that theta equals pi over 6 or 5 pi over 6 from the piece that says sine of theta equals 1/2. And we got that here by using our unit circle. And then for this piece, theta equals 3 pi over 2, which we did over here by using our unit circle. So when you see a complicated pre-calculus problem, it's a good strategy to try to make it look like a problem that you've already seen before in Algebra 1 or Algebra 2. And then the pre-calculus step will come at the very end where you're using this new skill, the unit circle. You can use these steps whenever you encounter a quadratic trigonometric function. When it's not quadratic, we'll have to come up with some new strategies, but the structure will still work. I hope this example is helpful, and please ask me questions if it doesn't make sense.